In Module 12, Section 3, we will look at solving equations by using the quadratic methods. Let me warn you now that a lot of these problems in this section will be long, and they will build on material that you learned in Modules maybe 9, 10, and 11, as well as the material you learned already in Module 12. So let's make sure you're very careful as you work these problems and check your work. Remember that when we are solving a quadratic equation, if the equation is in the form ax plus b all raised to the second power, so if you have some quantity raised to the second power and that equals a constant, you want to use the square root property to solve. If it's not in that form, we go to the next step, and we will write the equation in standard form by setting it equal to 0. You can always try to solve the equation by factoring. It's not necessary, but if you see that it's factorable and you liked factoring, then you can always try that with step 3. If it's not factorable, or you'd rather skip this step, we can go straight to solving by the quadratic formula. Now note that the directions on the previous slide did not include completing the square. Completing the square often involves more complicated computations with fractions, and it can be avoided just by using the quadratic formula. Let's try some examples. First, we want to solve 12x equals 4x squared plus 4. This isn't in a form where we have one quantity squared with no other variable, so we need to put it in standard form. So we subtract 12x from each side. That gives us 0 equals 4x squared minus 12x plus 4. Now, in very few of these problems will I actually factor, but I do like to take out the GCF if there is a GCF, because that makes your numbers that you will go through the quadratic equation with and the quadratic formula with much smaller. So here we notice that our polynomial has a GCF of 4. So if we factor out the 4, that leaves us with x squared minus 3x plus 1. Once we factor out a numerical constant in this section, we're not concerned with it any longer. It's not going to affect our answer. So we take what's remaining and we find our a, b, and c values. A equals 1, b equals -3, and c also equals 1. We plug this information into the quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. Plugging in will give us +3 plus or minus -3 squared, which is 9, minus 4 times a, which is 1, times c, which was also 1. All divided by 2 times a, or 2 times 1. This becomes 3 plus or minus the square root of 9 minus 4 all over 2, which is 3 plus or minus the square root of 5 over 2, and we're finished. We have our two answers. 3 plus square root 5 over 2, and 3 minus square root 5 over 2. Let's try another example. 5/8 m squared plus m minus 1/2 equals 0. Just like we've seen in previous sections, anytime we have an equation with fractions, we can eliminate the fractions. First, we find the LCD, and the LCD here is 8. So we multiply every term on both sides of the equations by 8, or in case of the fractions, 8 over 1. So as you multiply that, you will find that your resulting equation is 5m squared plus 8m minus 4 equals 0. Now, unlike the previous example, we don't have a GCF that we can factor, so we go straight to the quadratic formula. A equals 5, b equals 8, c equals -4. We plug that information into the quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. Plugging in gives us -8 plus or minus 8 squared is 64 minus 4 times 5 times -4 all over 2 times 5. So we continue to solve. We get -8 plus or minus the square root of 64. -4 times 5 is -20. -20 times -4 is a +80. All over 2 times 5 is 10. This reduces to -8 plus or minus the square root of 144 all over 10. Let's take this to the next slide and finish solving. So we had -8 plus or minus the square root of 144 all over 10. The square root of 144 is 12, so -8 plus or minus 12 over 10. we now have two different equations, or two different expressions. Negative 8 plus 12 over 10, which is 4 over 10, which reduces to 2/5. We also have negative 8 minus 12 over 10, which is negative 20 over 10, or just negative 2. The steps we detailed in solving quadratic equations will only work if the equation is in an obviously recognizable form. Sometimes we may have to alter the form of an equation to get it into a quadratic form. Sometimes this involves substitution, or squaring both sides of the equation, or converting from a rational algebraic expression to a different type of expression. So let's try a few problems where that might be necessary. Here we want to solve x minus square root of 2x equals 4. Remember in chapter 11, or module 11, we saw things like this. We would have to isolate the square root. So we start by subtracting x from both sides. That gives us negative square root 2x equals negative x plus 4. We can now divide both sides, or all three terms, by negative 1. And we're left with square root 2x equals positive x minus 4. So now we square both sides. And remember, when you square a binomial, that's the same thing as writing that binomial in multiplication twice. On the left-hand side, the square and the square root cancel, and we're left with 2x equals, on the right-hand side, we're going to FOIL. So we draw our FOIL arrows first, outer, inner, and last. Doing so gives us x squared minus 4x plus 16. We simplify a little bit more. 2x equals x squared minus 8x plus 16. If we subtract 2x from each side, this now becomes 0 equals x squared minus 10x plus 16. Now we have a quadratic equation in standard form. A equals 1, B equals negative 10, and C equals 16. We plug this information into the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Plugging in will give us positive 10 plus or minus the square root of negative 10 times negative 10 is 100, minus 4 times a, which is 1, times c, which is 16, all divided by 2 times 1. We reduce a little bit more. 10 plus or minus the square root of 100 minus 64 all over 2. And let's take what we have to the next slide. So we had 10 plus or minus the square root of 100 minus 64 all over 2. That reduces to 10 plus or minus the square root of 36 over 2, which becomes 10 plus or minus the square root of 36 is 6 all over 2. And now we have two options. We use the plus sign once. 10 plus 6 is 16 over 2, or 8. 10 minus 6 is 4 over 2, or 2. So we have two possible solutions. But hopefully you also remember that when we were dealing with square root equations, we had to plug back into the original and check our answer. So let's do that now. The original equation was x minus square root 2x equals 4. We have two possible solutions we need to check. Let's start with the first, x equals 8. That will give us 8 minus the square root of 2 times 8 equals 4, or 8 minus square root 16 equals 4, which becomes 8 minus square root of 16 is 4, and that does equal 4. Good. So x equals 8 is a good solution. Let's try it also with x equals 2. This is 2 minus square root of 2 times 2 equals 4, or 2 minus square root of 4 equals 4. The square root of 4 is 2, so 2 minus 2 does not equal 4. That would equal 0. So 2 is a bad solution. We get rid of the 2, and the only answer is 8. Let's try another example. Here we have 5 over x minus 2 plus 4 over x plus 2 equals 1. Remember, whenever we have fractions or algebraic fractions, we have to first find the LCD, make sure we get a common denominator everywhere, then we can cancel the denominator and continue to work. So we first write 1 over 1. We have a factor of x minus 2, x plus 2, and 1. So the LCD is going to be x plus 2, x minus 2. So let's multiply each term in the equation by the appropriate factors on top and bottom. In the first fraction, we already have an x minus 2, so we multiply by x plus 2 in the numerator and denominator. In the second term, we have an x plus 2 in the denominator, so we multiply by x minus 2 in the numerator and denominator. And on the right side of the equation, we don't have either term in numerator or denominator, so we have to multiply by both x plus 2 and x minus 2 in the numerator and denominator. Now that we have a common denominator, we can cross it out, and let's continue to simplify. We distribute the 5 in the first set of parentheses, and that becomes 5x plus 10, plus we distribute the 4 in the next set of parentheses, 4x minus 8 equals, in the last sets of parentheses, we have to FOIL. So we have first, outer, inner, and last, and this becomes x squared minus 2x squared plus 2x squared minus 4. And now let's combine like terms. On the right side, the 2x and negative 2x cancel. On the left side, we have a 5x and 4x, which makes 9x. We have 10 and negative 8, which makes a positive 2. So 9x plus 2 equals x squared minus 4. Let's use the room we have left to at least get this in a standard form, and then use the quadratic formula on the next slide. So we subtract 9x from each side, and we're left with 2 equals x squared minus 9x minus 4. If we now subtract 2 from each side, we're left with 0 equals x squared minus 9x minus 6. Let's use that information to plug into the quadratic formula. So 0 equals x squared minus 9x minus 6. So a equals 1, b equals negative 9, and c equals negative 6. We plug that into the quadratic formula, negative b plus or minus b squared minus 4ac all over 2a. Doing so will give us positive 9 plus or minus the square root of negative 9 squared is 81, minus 4 times a is 1 times c is negative 6, all divided by 2 times a, or 2 times 1. This becomes 9 plus or minus the square root of 81, negative 4 times 1 times negative 6 is positive 24, all divided by 2 times 1 is 2. If we continue to simplify, 9 plus or minus the square root of 105 all over 2. 105 isn't prime, but if we look at its prime factorization, 105 equals 5 times 21 or 5 times 3 times 7. There are no identical factor pairs that can be pulled out. So for that reason, we have this in the lowest terms we can get. So we have two answers, 9 plus square root of 105 over 2, and 9 minus square root 105 over 2. Let's try another example. And here we notice right away that we don't have the same kinds of exponents in this problem that we have in other problems. And that's an issue. So what we're going to do is we're going to substitute the variables we have with variables with exponents that we know how to deal with. Starting with the middle term, we will say that y equals x squared. If you were to then square both sides, you would get y squared equals x to the fourth. So in place of x to the fourth and x squared, we're going to put y squared and y. Now, we have to make sure we go back to these equations at the end to find the appropriate values for the appropriate variable. So let's start by subbing in. This becomes 9y squared plus 5y minus 4 equals 0. We know that a equals 9, b equals 5, and c equals negative 4. Plugging into the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a gives us negative 5 plus or minus the square root of 5 squared is 25 minus 4 times 9 times negative 4 all over 2 times 9. This will reduce to negative 5 plus or minus the square root of 25. Now we have to multiply the other three numbers together. We have negative 4 times 9 times negative 4. And when we do that, we'll have negative 4 times 9 is negative 36. Negative 36 times negative 4 will give us a positive 144. All over 18. We continue to simplify. Negative 5 plus or minus the square root of 169 all over 18, which becomes negative 5 plus or minus 169 is a perfect square. And when we take the square root, we don't need to write the radical anymore. So plus or minus 13 over 18. Our two answers for the y variable are y equals negative 5 minus 13, or negative 18 over 18, which would be negative 1, and negative 5 plus 13, which would be a positive 8 over 18, which reduces to 4 over 9. Now, these are the y variable answers. We started with an x variable, so we have to go back to our original substitution and find what values x would equal that would solve the original equation. So let's do that on the next slide. We had the substitution y equals x squared. We had the answers y equals negative 1 and y equals 4 over 9. Plugging in one at a time, first we plug in the negative 1. Negative 1 equals x squared. We would take the square root of each side. Remember, when we take a square root, we have to introduce a plus minus. The square root of negative 1, by definition, is I. So x equals plus or minus I. Now we have two answers, x equals I and negative I. If we plug in 4 over 9, we get 4 over 9 equals x squared. We take the square root of each side. Again, we introduce a plus or a minus. The square root of 4 is 2. The square root of 9 is 3. So x equals plus or minus 2/3. A positive 2/3 and a negative 2/3. So we actually have 4 answers to this equation. Let's try another example. Here we have 1 minus 1 over 6t minus 1 equals 6 over 6t minus 1 squared. Just like in the last example, let's substitute the value that is squared and the value that's not being squared with a easier variable to solve for. So let's take x equals 6t minus 1. If we square both sides, we would get x squared equals 6t minus 1 squared. If we make that substitution, our equation becomes 1 minus 1 over x equals 6 over x squared. At this point, we would make everything a fraction, and we try to get a common denominator. The least common denominator with x's would be x squared. So in the first term, I would need to multiply by x squared in the numerator and denominator. In the second term, I already have one factor of x, so I just need one more. In the third term, we already have x squared. At this point, we would have common denominators, so we can cancel those out because we have an equation. And the result would be x squared minus x equals 6. We continue to put this in standard form. We get x squared minus x minus 6 equals 0. Now, you might notice that this is a factorable polynomial. If you don't, then continue to work forward with the quadratic formula. Or if you would rather use the quadratic formula, do that. And that's what we're going to do in this example. Here, a equals 1, b equals negative 1, and c equals negative 6. We plug those into the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Now remember, we are solving for the x values right now. At the end of the problem, we will have to plug x back into the original substitution so that we can solve for t. But that being said, plugging in for a, b, and c, we get 1 plus or minus the square root of negative 1 squared is 1 minus 4 times a times c, so 4 times 1 times negative 6, all over 2 times a, or 2 times 1. We continue to work it out. This is 1 plus or minus the square root of 1 plus 24, all over 2, which is 1 plus or minus the square root of 25 over 2, which would become 1 plus or minus 5 over 2. When we work out each of these expressions, 1 plus 5 is 6 over 2, which is 3. 1 minus 5 is negative 4 over 2, which is negative 2. So we have our two x values, but we're not finished. We plug those into the substitution equation. So remember, the substitution equation was x equals 6t minus 1. We had two x values, x equals 3, x equals negative 2. one x value at a time, we're going to plug into the x in this equation and solve for t. So starting with 3, we get 3 equals 6t minus 1. We add 1 to both sides. We have 4 equals 6t. We then divide both sides by 6. We have t equals 4 over 6, which reduces to 2 over 3. Let's do the same thing with the negative 2. Negative 2 equals 6t minus 1. So we add 1 to each side. We're left with negative 1 equals 6t. We divide both sides by 6. And we have t equals negative 1/6. So we also have two answers for t. One is 2/3 and the other is negative 1/6. Let's try a word problem. Together, an experienced word processor and an apprentice word processor can create a document in 6 hours. Alone, the experienced word processor can process the document 2 hours faster than the apprentice. Find the time in which each person can create the document alone. Okay, so we have the experienced person, we have the apprentice, and we have the amount of time it takes them together. Now we know together it says they can complete one job in 6 hours. So just like we've done in previous examples like this, we want to know how much they can do in 1 hour. If it takes them 6 hours to complete the entire job, in 1 hour, together they can finish 1/6 of the job. Let's say that it takes the experienced person some X amount of time to finish a job. So in 1 hour, they would finish 1 over X. And let's look at how the experienced person's time and the apprentice's time are related. It says the experienced word processor can process the document 2 hours faster than the apprentice. And so if it took the experienced person 2 hours, it would take the apprentice 4 hours. If it took the experienced person 6 hours, it would take the apprentice 2 more hours, or 8 hours. So we're going to add 2 to the apprentice's time, 1 over x plus 2. We're adding 2 hours to the experienced person's time because it takes the apprentice 2 hours longer. So if we set up our equation, we know that the experienced person's rate, 1 over x, plus the apprentice's rate, x plus 2, will equal their total rate, 1 over 6. We now need a common denominator. Here we have 3 different factors. They're all unique, so that LCD is 6x, x plus 2. Let's multiply each fraction by the appropriate factors. In the first fraction, we need a 6 in the numerator and denominator, as well as a factor of x plus 2. In the second fraction, we need a factor of 6 and x, so we multiply by 6x in the numerator and denominator. And on the right-hand side, we need an x and an x plus 2. Once we do this, we have a common denominator, so we can scratch that out, and we can do a little bit of simplification. 6 times 1 in the first term is 6, so we distribute the 6 to both pieces. 6 times x is 6x, 6 times 2 is 12. In the second term, 1 times 6 is 6, 1 times 6x is 6x, so plus 6x equals, on the other side of the equation, 1x is just x, so we will distribute the x, which becomes x squared plus 2x. At this point, we combine like terms on the left-hand side. 12x plus 12 equals x squared plus 2x. We subtract 12x from each side, and we have x squared minus 10x equals 12. We subtract 12 from each side, and we are left with 0 equals x squared minus 10x minus 12. Let's take this to the next slide and use the quadratic formula. From the last slide, we had 0 equals x squared minus 10x minus 12. So A equals 1, B equals negative 10, and C equals negative 12. Plugging those into the quadratic formula, we have negative b plus or minus the square root of b squared minus 4ac all over 2a. This gives us positive 10 plus or minus negative 10 squared is 100 minus 4 times 1 times negative 12, all divided by 2 times 1. We can continue reducing, and this becomes 10 plus or minus the square root of 100 plus 48 all over 2, which is 10 plus or minus the square root of 148 all over 2. Now at this point, we could try to find a decimal representation of each answer if we chose to, and that's what we're going to do. 10 plus square root of 148 over 2. Its decimal approximation is 11.1. 10 minus square root of 148 over 2. Its decimal approximation is a negative value. And we can't have any negative values. So we know that the x value will be 11.1 hours. We said x represented the experienced person's time. It will take him 11.1 hours to finish the job. So the apprentice, who took 2 more hours, or x plus 2, will be approximately 13.1. Let's try one more example. Here we are told that Beach and Fargo are about 400 miles apart. A salesperson travels from Fargo to Beach one day at a certain speed. She returns to Fargo the next day and drives 10 miles per hour faster. Her total time was 14 2/3 hours. Find her speed to the beach and the return speed to Fargo. And so we have the picture below. We're told that she drives some speed when she starts at Fargo and goes to Beach, which is 400 miles away. And then she drives 10 miles per hour faster when she goes from the beach back to Fargo. Because we have distances and times and rates, we're going to use the formula distance equals rate times time. Also remember, we can rearrange this to have time equals distance over rate. So let's go to the next slide and use this information to set up our equation. Basically what we're going to have, because we were given a total time, is we'll have the time of the first written as distance over rate, plus the time of the return trip written as distance over rate, which will equal our total time. So we know the distance both times is 400. On the first trip from Fargo to the beach, we have the one speed, which we just labeled as x. On the return trip, the distance is the same, but we went 10 miles per hour faster. So the return speed was x plus 10 equals, we are told that the total time was 14 2/3. Let's start by eliminating this mixed number. We haven't seen very many mixed numbers in this class. The way you eliminate is by multiplying the denominator in the whole number and then adding the numerator. So we take 3 times 14 is 42, plus 2 is 44. So we could write this mixed number as 44 over 3. We're going to ignore the mixed number. At this point, we need a common denominator. The least common denominator will be 3x times x plus 10. In order to get a 3x, x plus 10 in each fraction, in the first fraction, we need to multiply by 3, as well as x plus 10. In the second fraction, we have to multiply by 3 and x. And in the third fraction, we have to multiply by x and x plus 10 in the numerator and the denominator. Doing so will give us a common denominator that we can cancel out. We do a little bit of simplification. 3 times 400 is 1200 times x plus 10 plus 1200x equals 44x times x plus 10. Let's distribute where it's necessary. So we distribute the 1200 into the parentheses, and we have 1200x plus 12,000 plus 1200x equals, let's distribute the 44x into the parentheses. This becomes 44x squared plus 440x. So we continue by combining like terms, and that will give us 2400x plus 12,000 equals 44x squared plus 440x. So we subtract 2400x from each side. We also subtract 12,000 from each side. When we do that, the 2400x and the 12,000 cancel on the left-hand side. On the right-hand side, we're left with 44x squared minus 1,960x minus 12,000. Let's take this equation in standard form to the next slide. So we had 0 equals 44 x squared minus 1960x minus 12,000. These would be very large numbers to go through the quadratic equation with. We might notice that the GCF is 4. So we're going to factor a 4. And remember, when we factor a 4, we are dividing every term by 4. And in doing so, the middle term becomes minus 490x. The last term is just a minus 3,000. So the numbers are still quite large, but not near as large as they were. When we factor out a numerical constant, it's unnecessary when we're using the quadratic formula. So we just cross it out. We now have A equals 11, B equals negative 490, and C equals negative 3,000. We take these pieces of information and put them into the quadratic formula, negative b plus or minus b squared minus 4ac all over 2a. Plugging in gives us a positive 490 plus or minus the square root of 490 squared minus 4 times 11 times negative 3,000, all divided by 2 times a, or 2 times 11. Let's try to clean this up as best as we can. This becomes 490 plus or minus the square root of, once you take 490 squared, negative 4 times 11 times negative 3,000, and put all of that together, you will get 372,100 all over 22. At this point, I would have no idea other than trying with the calculator, but 372,100 is a perfect square. And when you take the square root, you get 610. So 490 plus or minus 610 over 22. Let's deal with this on the next slide. So 490 plus or minus 610 all over 22. That breaks up 2 different ways. We have 490 plus 610 over 22 and 490 minus 610 over 22. Let's simplify each of these expressions. The first expression, 490 plus 610 over 22, comes out to equal 50. The second expression, 490 minus 610 over 22, will end up being a repeated decimal, but it really doesn't matter because it's a negative answer. We can't have a negative speed. So we know the speed, x, equals 50. And if you remember the drawing at the very beginning, x was the first speed, x plus 10 was the second speed. So we need to add 10 to our original speed, and we'll get 60 for x plus 10.